Okay, Bismillahirrahmanirrahim. The graphs of tan x. Um, when we have to learn how to draw the graph of tan x, we should relate this with the graphs of sin x and cos x. We'll be comparing or seeing that what are the differences or what are the um, differences in the steps taken to sketch the graph of tan x. Okay. The first main difference while drawing the graph of tan x is your marking on the horizontal axis. Okay, that is the first main difference. um, okay, for the sine and cos, you remember we were marking this after every 30 degrees. Now this will be marked after every 45 degrees. Okay, so please note it down. That is the first difference. Now you will be marking this after every 45 degrees. So there, the initial markings were always like whatever is the angle, whatever is the amplitude, whatever is there. Okay, initially you have to scale that at a difference of 90 degrees. But in a graph for tan, you have to keep this divided for 45 degrees. Okay, as I am doing it here. Acha. So that is the first thing that you remember, that how to mark your horizontal axis. And then secondly, you should remember ke jo, like its critical values jo hai, like if you have this, um, since we have 8 critical values of this tan x over 360 degrees, that is why we're marking this after every 45 degrees. Okay, that is the reason behind it. So you know that tan 0 is 0, tan 45 is 1, and then tan 90 is infinity, tan 135 is -1, tan 180 is 0, tan 225 is 1, tan 270 is again infinity, and here you have -1. Okay, so you see there is this infinity situation over here. Infinity is an undefined measure. We can't show it. So that is why you will have the asymptotes in your graph over here. Okay. So the asymptote is a word you might be hearing this for the first time. The asymptote is a very cute word, asymptote. Okay. So you can keep your name as asymptote as well, okay? Fla asymptote. Or you can keep your pet's name as asymptote as well. Anyhow, this is up to you. And now I have to show you how do you keep asymptote over here. Now this has to be a dotted line. Now this zoom does not allow me to draw a dotted line. So I am going to filhal draw a solid line, but you guys will have a dotted line. Let me make it dotted. I have adopted a way here to make it dotted. So yes. Okay, so I have made it a dotted line. Okay, so this asymptote has to be a dotted line. Okay, now let's draw its graph. You see how to draw it.
Sir, so
Ta-da.
yes, asymptote, what is this?
Asymptote is a vertical line that is used to represent the infinity on your graph. Because you see your tan 90 over here, that is infinity. Can you see this? Oh, this tan 90 over here. This is infinity, है ना? So we don't know how big is this infinity. So I can't mark, like if I have a y coordinate, which is let's say 2, 3, 5, so I can mark that clearly on this Cartesian plane or on this grid. Lekin this infinity is an undefined value, so we can't show that. So look at this, how I'll be showing it. I know that tan 0 is 0, then tan 45 is 1. So I'll be drawing it like this. So I'll just show it going upward with this asymptote. Okay. and this asymptote is like this. So this graph is going to be going like this. That is it. So this is the function of this asymptote. We are showing that if your values of x move towards the 90 degrees, the values of y, they are moving towards infinity. Okay? And then you see that again, it is on the axis at 180 degrees. So here it is 1 and here it is -1. Okay. So this part is going to be like this, going upward. And this part is going to be like this, going downwards here. Okay. With the um asymptote. Okay. Uh, Unlike the graphs of sine and cos, you will not have the that package kg x is maximum, x is minimum, x is kind of a thing will not be here. Now there are some tips that you can remember so that you can draw this accurately. Remember, whenever you have an asymptote on this graph of tan x, or when you will be studying cotangent x in your P3, remember that if the asymptote has infinity uh, towards the positive y-axis on one side, the other side will have this going towards the negative side. Look at this, like this asymptote, this is going upwards here, and this is going downwards over here. So uh, if one side of the asymptote has infinity going upwards, the other side will have it downward. That is a clue for you. Okay, so that is how you can maintain the flow of this curve. So you can continue drawing these parts, like this will be going upwards like this, and then there will be an asymptote over here. Like if you want to continue drawing this for the some, like, right, so this would be like this will be coming towards this. Okay, so you can see that this is not a continuous function. The curve is always going to break whenever this approaches infinity. Can someone tell me that what is the period over here? Only the I'm asking from the math students, because ad math people know this already. What do you think, what is the period of this function tan x? मैथ वाले बच्चों, the sine and cos had a period of 360 degrees. So what is the period of this function here? Hmm? Any guess? Chale, add mass वालों, can you tell us what is the period here?
180 degrees.
180 degrees. Can you explain this to the add mass people, that why do you think this is 180 degrees?
Because after 180 degrees, the graph basically repeats itself.
Yeah, and you see that there all these pieces of these curves, like if you look at this block here, this is exactly drawn within 180 degrees, like from 90 to 180. Look at the next part. This is drawn in another 180 degrees, okay? Even this graph would be between -90 and 90, okay? So that is why the period of this tan is going to be 180 degrees, okay? So the period of tan x is 180 degrees, while the period of the sine x or the cos x, that was 360 degrees. Okay? Now, can we have the amplitude of the graph of tan x? Remember, yesterday we have talked about the amplitude as well. Like if you have a curve like this is going to be this and this, then this much was the amplitude. The distance between the axis and the highest or the lowest point on this curve, that was your amplitude,
This
okay?
curve doesn't इसका highest or lowest point होता नहीं है.
Yeah, so that means there
No
is
amplitude.
there is no amplitude, okay? Give me a minute, please. let's add spices into this simple graph of tan x. Okay, so as I was telling you that when you have y is equal to a sine bx plus c, you can also ask to we draw the graph of a tan bx plus c. Okay, now uh, this c is the axis of the curve about which the curve is going to move, axis of the curve. Okay, this c is also the axis of the curve here. Okay, now this a is the amplitude here. Okay, this a is literally insignificant here, but obviously this will tell you to determine, this can help you to determine the direction of the curve. Okay, if it is positive, the curve will be normal. If it is negative, you will revert the curve. Okay, but this a is not representing, it is not the amplitude. That is one thing, because you have seen in your graph here, I can show you again, there is no maximum minimum value. On the maximum this goes up to infinity, on the minimum this goes down towards the negative infinity. Okay, so a is in that case is not representing the amplitude, but this way this a will definitely help to determine this value of 1 over here. Do you remember this 1 and minus 1 was also there in the graphs of sine and cos, but these ones and minus 1, these were the maximum and the minimum value. But here, this tan 45 is 1, so we can determine these values of 1, how they can change if you have this I mean a over here. Like for example, if you have y is equal to tan x. Okay, if it is y equal to tan x, so here you have these values are going to be 1, 1, minus 1, and minus 1. And guess if it is y equal to 2 tan x instead. So what would be these values now? You bacho? You see, here you have 0, 0, and infinity and infinity. If you multiply 0 with anything, it remains 0. You multiply infinity with anything, that remains infinity. Yes, these ones will change. So this will be 2, this will be minus 2, this is going to be 2, this is going to be minus 2. Okay. So suppose you want to sketch the graph of y equal to 2 tan x. So this would be something like this. Like instead of 1, I'll write 2 over here. I'll write minus 2 over here. And then I have 45 degrees intervals. Okay, like this. And then I have the asymptote at this 90 here, the asymptote at 270 degrees here. So the curve is going to go like this, this, and then this, and then this. Okay, so that is the graph of y is equal to 2 tan x. Okay, then this b over here, this b is, in this case, this helps you to determine the period. Okay, 360 over b is the period here. Like if you have sine 2x, the period becomes 180. Sine 3x, the period is going to be 120 degrees. In this, its function is the same, but uh, the period of tan is normally 180 degrees. So this is 180 over b. That will be the period of this function in x, in tan x maybe. Okay, so let's try drawing the graph of let's say you have to draw y is equal to um, 3 tan 2x minus 2, let's say. Okay, you try this first and then I'll draw it for you. Okay, first of all, you will have the intervals of 45 degrees. Let me take this time in terms of pi. So we have pi by 4, we have pi by 2. Look at this, how I'm writing this so conveniently. 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, and then 8 pi by 4. Okay. Because of this 2x over here, I need to divide all these intervals into further into two parts. Okay. Okay, as we were doing in the case of sine and the cos. So if you have 2x, you divide this into two parts. Now, half of pi by 4 is pi by 8. Look at this, how I'll be writing this. Pi by 8, 2 pi by 8, 3 pi by 8, 4 pi by 8, 5 pi by 8, 6 pi by 8, 7 pi by 8, 8 pi by 8, 9 pi by 8, 10 pi by 8, 11 pi by 8, 12, and then this is 13 pi by 8. This is 15 pi by 8, and this is 16 pi by 8. You can see that that is going to be 2 pi. Okay, next is the axis of this curve that is at -2. So let me keep that -2 over here. Let's say -2 is going to be, this is -1, -2. Here it is -2. Then you have 1, 2, 3. You have -5 here. Okay, this is 1, 2, 3. You have 1. Okay, so -2 plus 3 is that, like normally you have these 1, -1, 1 and -1. So adjusting the new values for 1 and -1, they will be 1 and -5. Okay. Now it's a time to show the asymptotes. Normally your first asymptote is at 90 degrees over here. So what is half of 90? That is pi by 4, or 45 degrees. So I'll have my first asymptote at 45 degrees. Okay. I'll first draw them solid and then I'll be drawing them uh, dotted. I'll make them dotted. Okay. So here is my first asymptote. Okay. At pi by 4. Okay, this is your first asymptote at pi by 4. Okay, the next asymptote normally comes after every 180 degrees or pi radians. Okay, so this will be coming after pi by 2. Okay, so pi by 4 plus pi by 2 is basically, that is 2 pi by 4. So you will have your next asymptote at 3 pi by 4. So here is your 3 pi by 4. So this is your 3 pi by 4 here. Okay. And you can count these points over here as like 1, 2, 3, 4. Then you have 1, 2, 3, 4. So here is your next asymptote. Please look at these steps so that you can draw this easily. And then again, 1, 2, 3, 4. So I have my next asymptote here.
सर मेरा इंटरनेट ना बड़ा अटक रहा है, आप थोड़ा सा एक्सप्लेन कर सकते हैं फिर से आपने लाइंस कैसे लगाई हैं?
I'll tell you again, beta. देखिए, normally your asymptote is happening here. Can you see this? It is happening here at 90 degrees. And because of this 2x, where should I draw this? Yes, tell me quickly.
45.
45 degrees. So pi by 4 is 45 degrees. Okay, first thing is you must mark your first asymptote correctly. Okay, after that, if it was just tan x, after how many degrees you should have the next asymptote?
180.
180 degrees. But because of this 2x over here, you will have your next asymptote after every 90 degrees or after every pi by 2. Got it? I
Okay,
haven't
sir.
drawn
Thank
I
you.
haven't drawn that dotted line for the this axis of the curve. So this is going to be your axis of the curve here. Okay? So this is the axis of the curve. Let me make them dotted quickly. So this, oh, sorry. This is your axis of the curve. This should be dotted. And these asymptotes should also be dotted, okay? So we are ready to sketch the graph of y is equal to. Please, बच्चों, do ask me about anything if it is unclear to you. Please अभी पूछ लो, बाद में फिर आपने तांग बने. अभी पूछ लो कि फ्ला चीज कैसे आई है, या why that is there, या ये क्यों नहीं किया, या वो क्यों नहीं किया. अभी पूछ ले. Okay, if you're not asking, so then I'm going to draw this sketch now, okay? So here is a curve for this y is equal to like, I'll take a point here. So it is going to be like this. I'll be drawing these parts. It is easier to draw it if I draw the positive part of the curve first. Okay. I like doing this. So these are the positive parts of the curve. And now I'll be drawing the negative parts of the curve. It is at -5 here. Oh, this is so nice. I love these colors, these graphs, okay? So that is how you have the graph for this y is equal to this tan 3 tan 2x and with a -2 with that. Any question, Vacho? So let's move on to the exercise then, and we practice the graphs from there. So here is the exercise that you must practice. Acha, there is one thing that we haven't discussed so far. You people know that how would you adjust your graph if you have a composite angle like 2x or 3x, but we haven't discussed so far that what if you have an angle like, suppose you have y is equal to sine half x. So how would you adjust this? Like, here is this b part. So how would you handle this one? Y is equal to sine half x.
The period
Yeah,
becomes 720.
yeah, exactly. So that means within 360 degrees, you will have only half of the curve, okay? Like this is 90, this is 180, this is 270, this is 360, you have one here, you have -1 here, okay? So instead of dividing them into two parts, we'll skip this part over here, okay? So I'll write 90 over here. We'll skip this part, I'll write 180 over here. बच्चों please पूछ लो यार. You see, when there is y is equal to sine 2x, so what do? You divide all these intervals into further two parts. Like if it is 90 here, you show this 45 and then 135 and then 180 and then you have 225, 270 and all that, okay? So that you can have two curves within this 360 degrees, okay? But in this case, look at this, how this curve will be drawn. When you have sine half x, so you will skip this 90 and then 180 has become 90 and this is going to be, so you will have half the curve because as one of you have told, okay, this curve will now be completed. Oh, this is,
Sir, one ये आधा बनेगा
yeah.
आपने पूरा बना दिया.
Yes, beta. This is 180. This is 360. So, because here was 90, we have to skip that. Here is 270. We have to skip that. Okay. So this is how the curve would look like if it is going to be y equal to sine half x. You will have a half the curve in 360 degrees. And here you had two curves within 360 degrees because of this 2x. So this half is a clue for you. Half is going to be half of the curve. 2 is going to be the two curves. So this will change your this function period. This is 360 over half. You see that is going to be 720. That means one wavelength will be completed in 720 degrees rather than 360 degrees. Now please try these questions.
Sir, आप हमने 2 का पार्ट ई वाले अभी ड्रॉ करने सीखे हैं 2x + 60 वाला
nahi beta, not at all. Don't try these questions here. Once you're done with the functions, then you will learn how to do this. Don't do these questions, don't do this one, okay?